Welcome to our video for Unit 7, Lesson 2, where we're going to be working with writing equations of lines and comparing slopes of parallel and perpendicular lines. So, first is just a review of parallel and perpendicular lines. So, you guys know that parallel lines don't touch, and perpendicular lines, when they meet, they're forming those 90-degree angles. So, we've been dealing with a lot of this in our quadrilateral unit, but now we're kind of just bringing it to a coordinate grid and showing it in that way. So for our slopes, which we kind of went over in the previous lesson, you guys have to know these two things. So slopes of parallel lines are always the same. If the slopes of two lines were different, that would mean that the lines would be different, which would make them eventually intersect, right? Like even if the slope of this bottom line here was a little bit different, eventually they would cross and touch, which go against the parallel line definition. Now, perpendicular lines have slopes that are negative reciprocals of one another. So this word, negative reciprocals, or these two words, are fancy ways of saying what we are about to go over. So make sure that you know those two things. So what is a negative reciprocal? You need to flip the fraction of the slope and you need to change the sign. So in this case, we have A and B as our original slope. So if we flip that fraction around, we get B over A, but then we also need to add that negative sign in it. And if it was negative, switching the sign you'd have to have a positive slope. So we're going to find the slopes of these lines passing through these 2 points, and we're going to determine the slope of a line that would be perpendicular to it. So this is a refresher of yesterday as well. That slope is y2 minus y1 over x2 minus x1, and what I like to do is label right away. So x1, y1, x2, y2, and we need to be really mindful of our signs because they will change our answer. So our y2 is negative 20 minus 0, which is our y1, over x2, which is 21, minus 6. And then if we do this, we're going to get negative 20 over 15. So that's our original slope. That's the slope of this line that passes through these 2 points. But if we want the slope to be perpendicular, if we want the slope of the new line to be perpendicular, we need to take the negative reciprocal of this slope. So again, I usually like to write it like this, m perpendicular, like the slope of a perpendicular line, equals, and again, we have to flip that fraction around, so 15 over 20, and we need to change the sign. So originally we had this negative sign here, so our perpendicular slope must be positive. So there we go for that one. Now I'm going to skip this middle one just so we have enough room, and we'll go ahead straight to this third one over here. So x1, y1, x2, y2. And I like to write the formula. Like, it's tedious and it takes time, but it will prevent you from making mistakes. So x2 minus x1, and now we can go ahead and substitute. So again, this is finding the slope of a line that would pass through these 2 points right here. So we have negative 6 minus 6 over negative 9 minus our x1, which is negative 5. So go very slow here because things can get very messy if you forget to incorporate your sign. So we have negative 12 as our numerator, and our denominator changes to negative 9 plus 5, which is negative 4. Then when we simplify this, we get 3. Because when you have a negative over a negative, that becomes positive. Now another way you should be used to seeing this is 3 over 1. 3 or 3 over 1. Now when you write it in this fractional form, it kind of helps you see how to find the negative reciprocal. So again, for this perpendicular slope, we need the negative reciprocal of 3 over 1. So we flip that fraction and we change the sign. Okay? Wonderful. So this next part is we're going to be writing or evaluating equations using kind of what we just said about parallel and perpendicular slopes to compare lines, basically. So just as a refresher of slope-intercept form and point-slope form. So you might be given 2 lines like this, and you might be asked, hey, are they parallel, perpendicular, the same line, or neither? Now, the parallel and perpendicular part strictly depends on slopes. You're evaluating the slopes. Now, if it is an example like this, where your equations are in the same form and they're both already in y equals, then you're pretty much good to go. So again, with this form, we know that the slope is the number next to the x. So if there's no number, if there's just, you put imaginary 1 there. So the slope of this line is 1, or 1 over 1, I guess. And then the slope of this line is also 1, or 1 over 1. Now we know for a fact that these would be parallel because they have the same slope, but we got to check if it's the same line. If it's the same line, it's going to have the same exact equation when you simplify it. But here we can see that our y-intercept here is 8 and our y-intercept is 4. So those are going to be two different lines. So the lines are parallel because slopes are the same. Okay. Now, we might have a more complex example like this one where we need to manipulate our equations a little bit. So we have y equals negative 5 over 4x plus 3. And then we got this crazy looking one, 16y minus 20x equals negative 16. So right now, when the equation is in this form, we can't see any information about it, right? But this is when we manipulate and we get it into y equals. So don't make the mistake of being, oh, the slope is negative 20. No. You have to get it into y equals first. So first, we can add 20x. We'll get 16y equals 20x minus 16. And I'm putting the x term, the 20x, in front, just because this is kind of how we're used to seeing that, right? Y equals mx plus b. So that term with the x should go first, just to be consistent. Then, again, we're not done. We have 16y. We need to divide everything by 16. So we get y equals 20 over 16 times x, and then minus negative 16 divided by 16 is 1. Then when we simplify, we will get 5 over 4x minus 1. And you want to simplify as much as possible, because if I stopped at this line right here, I can't really compare those numbers yet. But here are our two equations. So again, parallel lines have the same slope. So here, I like to write this out as well. Here, our slope is negative 5 over 4. Here, our slope is 5 over 4. So we're comparing these two numbers right now. So they're not the same exact number. The signs are different, which matters, so I know it can't be parallel. Perpendicular has to be negative reciprocal, which means the fraction should be flipped and the sign should be different. Now, while the signs are different, the number is not, the fraction is not flipped, so it can't be perpendicular. Now, the same line, we would have to have the same exact equation. This is not the same exact equation at all, right? So this is going to be neither. And your explanation would be neither because slopes are not the same, so not parallel, and slopes are not negative reciprocals. So, not perpendicular. Okay? Now again, if the question says to explain, you need to be going in depth in your explanation. Now, here's the last one, where we have our point slope form. So remember, for point slope form, the slope is just whatever's outside of the parentheses. So here, this is a little bit easier. Here our slope is 3. Here our slope is negative 1/3. And again, this is why it helps to write it as 3 over 1, because now you can kind of see the slopes aren't the same, so our lines are not parallel, but these slopes are negative reciprocals of each other. So lines are perpendicular because slopes are negative reciprocals. Great. Now, we're going to go into writing equations of lines. So you're going to be writing equations in both of these forms. So you need to know the information that you need in order to write that equation. So for slope-intercept form, or for both of them, you need the slope and you need a point on the line. But for slope-intercept form, we have this variable b here, which is our y-intercept, that we need. So slope-intercept form sometimes takes an extra step. So let's just we're going to go into two examples. So example number 1 says, what is the equation of a line that passes through the point negative 4, 8, and has a slope of negative 1/2? So let's do it in point slope form first. Point slope form is a little bit easier because we already have the two things we need. We have the slope and we have a point on the line. So when we're writing it out in point slope form, just remember, like this would be your x1, this would be your y1. Just remember when you're doing that, you have to flip the sign. So it's not going to be y plus 8. It's going to be y minus 8 equals our slope, which is negative 1/2, times x, and then our x1 is negative 4. And we just got to flip that sign, so x plus 4. Now, slope-intercept form is a little harder. So we already know our slope. We can check that off. We have a point on the line. We can check that off. But now we need our y-intercept. So we're going to use this given information with this equation here to help us find what b is. So our y value is 8 equals our slope is negative 1/2 times our x value of negative 4 plus b. Now that we've substituted, we'll be able to actually solve. So we have 8 equals, and if you do negative 1/2 times negative 4, you're going to get positive 2 plus b. Now we do some algebra and subtract 2 on both sides, and we get that 6 is our b value. So now our y-intercept we have, and now we can just rewrite our equation. So y equals, our slope is negative 1/2, x plus 6. Okay. Now, one more example is if we're writing the equation of a line that passes through 2 points, we need to do a little bit of extra work here. So in the last question, it gave us the slope, but in this question, we got to do some math to actually find the slope. And we need the slope for both forms. So remember, slope is y2 minus y1 over x2 minus x1, and I like to label right away, x2, y2. And then we substitute. So our y2 is negative 2 minus negative 4 over 2 minus 9. And then if we solve that, remember these two negatives become addition. Positive 2 over 7. Good. So now we have our slope. We can actually check that off for both of them. And point slope form, we can get out right out of the way right now. Now for point slope form, you only need 1 point on the line, so you can choose 2 things. You can either write it using this point, and if you did that, it would be y plus 4 equals our slope, which is negative 2 over 7, times x minus 9, or we can use the other point here. And if we did that, it would be y plus 2 equals, again, negative 2 over 7 times x, and then we would have minus 2 here, okay? So for point slope form, you can choose whichever point you would like. Now, for the other one, we still need our y-intercept, right? So remember, for slope-intercept form, you need to go that extra step where you're substituting in your given information. And again, it doesn't matter the point that you choose, but you need to substitute a point into y equals mx plus b with your slope so that you can actually find your y-intercept. So I'm going to use the first point. So negative 4 equals negative 2 over 7 times 9 plus b. And then we get negative 18 over 7 plus b. And then you would have to add this fractional value on both sides. I don't know exactly the value. I don't have a calculator on me, but whatever value you get for b, you have to go ahead and put into your equation. So y equals negative 2 over 7x, and then plus whatever number that you get for that one. Okay, so that's all. Make sure that you know with slope-intercept form that you just have to go that extra step in actually finding your b value.